So today we are going to discuss about machine learning prototype to production. So this is the link of my presentation. So if anyone wants to access the presentation, you can go to my GitHub link, and this is the particular page you can actually scan. So if you just point your camera to this, you'll be able to scan it, and that will lead you to this particular GitHub page. Okay. And if you go to the slides section, it has the slides. So let me present it. So before I start, actually, just wanted to say thanks to everyone who joined the session, and also for Patrick to give a very insightful session before my session. So it's quite insightful. Definitely we should look forward for those kind of graphs and network in the data. And today, I'm going to discuss about how we can build machine learning models from prototype to production. Okay. And this is a kind of a namaste gesture from India. I belong from India. So let me give you a brief about myself. So I'm Krishna Kumar Tiwari, and I'm having 10 plus years of experience in machine learning domain. I have I love to do machine learning at scale. That is the kind of a thing I know about myself, and I'm proud founder of MLAI community. You can check out ml-ai.in. I'm part of member of advisory board at AI Forum. I'm a failed serial entrepreneur, and currently in my current role, I work for machine learning architect at Geo. And prior to that, I've worked with InMobi, Samsung, Oracle. I've started a few companies and started my career with IBM Research Lab. So this is the kind of a brief introduction about myself. If you have any questions, maybe you can scan this link. It will directly lead to my profile. Just wanted to confirm that everyone is able to see me. I think, can someone confirm? I hope so. Okay, so let me start again then. Yeah, so let me discuss about why I have chosen this particular topic actually. So if you see the recent change in last 5 years, so it's not like data scientist or machine learning engineer, you just need to think about the model part. You need to also think about how my machine learning model or the intelligence which I'm building right now, it will go to the production. Okay, and that's why this kind of a mentality change or the kind of a mind shift is required. And that lead me to discuss about how you can, when you are building your machine learning models or when you're building your intelligence or you're dealing with a data science project, how you can structure your thoughts and what all different tools and techniques can help you to make prototypes which can work for production. So today, in today's agenda, we'll be discussing about the building blocks. We'll be discussing about what is prototype and what all things you can use in a prototype. And then we'll covering the model training pipelines, model deployment pipelines, health of the system, and the techniques which you can apply for ML at scale. And finally, the performance evaluation. Okay. And everything, whatever we are discussing, the idea of this talk is to think about those things from day zero. So when you're thinking about building a kind of a prototype, the things which we are going to discuss now in next 20 minutes, it is going to help you to structure your thoughts in a way. Yeah. So the first thing is, okay, building blocks or the mental map, right? So when it comes to the first thing which is required, which I felt quite important, is to understand the difference between the engineering and the data science project. Also thinking about how to define the problems. What are the different key things to consider given a generic machine learning or data science problem, and the kind of a life cycle. So if we talk about the core difference between the engineering and data science project and the thing where we need to prepare ourselves, right? That is the uncertainty. So if you see any data science or machine learning project, right, there will be uncertainty involved in that process. And trust me, it's impossible to remove that uncertainty because everything works on some kind of probabilistic way or the inference, and it basically you're using statistics or different kind of a discipline to generate something, right? So definitely there will be some kind of an angle of probabilities. So definitely it will have some uncertainty. So what we need to do is, we need to, when we are dealing with data science project, right, to deal with the uncertainty, we need to come up with the kind of fallback options. So saying that if my model doesn't work, what will be my fallback in that kind of a scenario? Defining the problem statement. So when it comes to define the problem statement, if you compare with the engineering domain, you define the scope of things. Same thing comes under machine learning or data science also. But you need to dig deep. For example, you need to see with a lens that, okay, it's a kind of a regression problem, classification problem, or what kind of a domain it is going. It is a supervised, unsupervised, structural, unstructured kind of a way. You need to first give it a shot like that. And then comes the like if you are an AI leader who basically take care of a machine learning project or data science project, in that case, it becomes the prime responsibility to get the kind of domain knowledge already exists, because the business team will have some kind of a knowledge, product team will have some kind of a knowledge, engineering will have some kind of a knowledge. So if you capture all those data in advance, right, that is definitely going to help you with the coming up with the right kind of a uh, problem statement, or defining your problem in a substructure manner. What I mean with that is, given for example, if someone gives you that, okay, we need to work on something where we need to build a kind of a recommendation system and increase the revenue of the system, or increase the watch time of a user, right? So that is the kind of a problem if you're solving, right? There are multiple sub problem associated with it. Maybe you can say that, okay, is whatever content I'm showing to a particular user, that is the right content or not? Is the artwork is correct or not? What is the kind of a click rate it is coming? Okay, do we have shown the right kind of content where we have already seen that this guy has liked it, right? Or what is the kind of a show, if I see the social profile, what is the kind of other people in his network are liking, and what we can infer from that, right? So there are different kind of problems which you can define, and if you solve all those things in parallel and take those levers, there's a good chance that you will be going for a global maximum kind of a global optimization kind of a way. The other thing which you need to think as key thing to consider as is the one matrix that matters to you. For example, if I'm solving a classification kind of a problem where we have some kind of a two class classification problem, right? So if for that kind of a problem, if my F1 score is the right kind of a matrix which says that, okay, this model is better or this particular run is better, we should know that matrix in advance. And we should also know the definition of that data science matrix or machine learning matrix definition translated to the business matrix also. Maybe F1 score will be not, maybe a business team will not understand F1 score. So you need to translate that to make sure that if your F1 score is good, maybe I'm saying that my targeting is right. Okay, so all those things you need to take care in advance. You also need to think about what will be the consumer of the model, what kind of a scale it will be. Okay, it will be what kind of a latency you need to provide. Okay, what kind of a throughput you need to support. So all those things, it's better to, while the scoping of the project, when you're trying to do something, right, it's better to think about that. Lifecycle I will not cover much, because pretty much it is the kind of a standard everyone follows, where you have some kind of a scoping cycle, then you do research, then you do the deployment, development and the deployment. And in this cycle, when if your model, whatever you researched, right, if it is not working well, so in that case, it's not working well in your production, right, again it goes for a iterative cycle like that. There is a chance that whenever you're trying some kind of a problem, and there could be instances where you need to change the scope itself. So there are multiple iterations possible on this kind of a life cycle. But pretty much this is the kind of four ways you can define, four steps you can define for the life cycle of a data science. Okay, so till now we have seen the kind of theory, right? So we have seen that, okay, this is the way to define your project, define the sub problems, and then choosing the right kind of a matrix for it. Okay, but what happens at when, if you see the agenda of this talk, right, it is prototype to production, right? So what, when we say the prototype, right, it is pretty much you're trying something based on some kind of a hypothesis or kind of a sample model which you want to get it success and take it to production, right? So for that, the key term which I would say that the takeaway from this presentation or this session will be how to think about that from the day zero. Okay, and trust me, it's not going to be easy. It's going to be a really hard problem, but it is the kind of a right practice to follow the same. Okay, and if we say that, if we bear the pain, that particular pain, for maybe one or two iterations, it becomes kind of a practice in the organization to follow that, and it is kind of a way that maybe the further iterations will be quite easy to do and quite manageable. So let's talk about this prototype part first. So when we say about the prototype, right, we start, if you see data science or machine learning, right, you start with some kind of a hypothesis saying that, okay, I want to maybe I believe that this particular data point is true, or I have some kind of a classification or some kind of a way that I want to apply maybe traditional machine learning or deep learning way of solving that kind of a problem, right? So you first start with setting up the dev environment where it will have the Jupyter hubs or Databricks, or you will have the right kind of a mounting to get the data access to your notebooks, right? So you will definitely, this is the kind of a P0 item, or what is a prerequisite to start a prototype. The other thing which I consider equally important is, if you have the domain knowledge, if you have captured the domain knowledge, you need to first think about how to define the base model. Okay, how to define that. When I say that I have produced some kind of an intelligence, so in that case, if you have some kind of a domain knowledge, and on top of it, if you're able to write a custom code or a kind of a code which is just translation of those what is a domain knowledge, then you can say that you need to perform something better than that. Okay, so that becomes, that is the kind of a way to think about. When you think about solving a particular use case, you should know that, okay, what is the bare minimum which is available in kind of a domain knowledge itself. The second is, okay, and right now people are trying starting with the deep learning, but it is always recommended to go ahead and check for the traditional ML way also, using scikit-learns, or using uh, things which are coming from a combination of statistics plus ML side of word, and then moving ahead and comparing all these things to the complex model which you cannot explain, like neural net. So there are advantage and disadvantage of both the things. For example, if you go for the traditional word models, if you are trying some kind of a tree model, it's quite easy to explain. But if you go for deep neural way of modeling, it will be not explained, will kind of a black box kind of a way. The other thing is, you need to choose between the kind of data you are dealing with. For example, when you're doing the prototype, it's possible that you're dealing with lesser amount of data, and maybe at that moment using a non-Spark kind of a way works well. Maybe you're writing your pipelines in Python. Okay, but usually most of the big giants, when you deal with petabytes of data, terabytes of data, in that cases you need distributed setup to deal with those kind of a data. So you should think about that from day zero, that this could be the scenario when I move forward. uh, One is like AutoML, or I also say it as kind of new data scientist in town, because what happens is, yeah, it will be not a production ready thing. Okay, but you can try it out in your production time, because that way it tries. If you're in a cloud world and you're trying AutoML, right, you have multiple models which gets tried using AutoML. It tries multiple hyperparameter tuning, and that way you get a sense of thing that, okay, you get a kind of a filtered set that maybe out of 100 models I can focus on these two algorithms, and then I need to perform something better than AutoML. So this is the kind of a way you can make your prototype fast. So if you're trying something, if you're using an AutoML help and then building on top of it, maybe there is a chance that uh, to finalize your model, right, you will take lesser time compared to if you try it manually for all those models, right? And in this slide, one important part is, you should be clear enough in the first step itself that what is that one matrix that matters to you. Okay, and ideally this should come from your product or the business team, but you should have a right alignment on that before starting your prototype. So the important part when you're doing your ML or building something in your notebook, right, many times we don't think about how my model training pipeline will look like, how my model deployment will look like, right? But it is always recommended to think about few other practices which is mentioned here. For example, my model is a batch or real-time processing model, so it will have the real-time training. When I get an event, do I need to train at that particular moment, or the events are getting stored to some place and then there's a bad job which runs on that data. Okay, so there are decent enough examples of both the techniques. It depend upon your business use case. For example, if you are in a ad tech world, maybe it is, everyone wants to be close to the real time actually. Okay, but many times it's not possible also, and it's not recommended also. For example, if I need to train someone's user profile, get him some signal, one signal, two signal, maybe that is not good enough to take any judgment. But if I have signal for maybe 7 days kind of a data or 3 days kind of a data, maybe that makes sense. So based on the business logic, based on the kind of problem you're solving, you need to think about what kind of a model training you need to do. While thinking about that, it is important to think about what is the common pattern there and defining what all can be defined as a step. So we see, I'm not put a diagram here, but if you see it, that's quite famous in machine learning, where you say that, okay, you have some kind of a data, then you do the pre-processing, then you do feature engineering, then you do modeling and the validation, like that, right? So what all these things are? These things are kind of steps, right? And this is part of a workflow or a kind of a pipeline. Uh, if you see any of your job, right, there is a chance that you will have, maybe in pre-processing itself, right, there is a chance that you can have multiple type of pre-processing. There is a chance that you can have different kind of feature engineering. So whatever you're able to get it as a common, it is right practice to get those common patterns, get those common methodologies, methods, and define the steps. Okay, you can use scikit-learn for the definition of the whole pipeline of the workflow, or you can use AML pipelining also. Like if you're in the cloud world, if you're using Azure, you can use AML. Equivalent is available on Google and Amazon Cloud also, right? So the other part, when you have defined your, that it is a kind of a batch processing and I'm using maybe scikit-learn kind of a pipeline, right? Still it is important to understand that when you're training your model, there is a good chance that you will be running multiple jobs, you will be doing hyperparameter tuning, you will be doing multiple things actually. Okay, and in that, what is more important is you should take care about the different runs, and you should take care about the different runs, parameters, artifacts, whatever you have got actually. And one way to do that is, okay, you are keeping all this data, logging this data somewhere, but there are standard platforms which can do this. And I would say that this is the kind of a thing which pretty much most of the standard platforms follow, or it is recommended for any of the automation to follow MLflow or Kubeflow kind of a setup, or alternatives compared to this, where you can do the ML end-to-end kind of a tracking. And what that tracking means is you are able to track your runs, you are able to track everything, artifacts, you are able to track the different measurement of the metrics which matters to you. So that is the kind of a thing you can think from day zero. And when it comes to the model deployment, right, so model deployment also has two choices actually. So you can think it as, okay, my model is actually running as kind of a batch job, or my model is running as a real time. Okay, so if I talk about the batch job, it will be some kind of a job itself where you're calling that predict method of that particular learning which you have done, or you have stored some kind of a learning in some kind of a data store, then you're just doing kind of a lookup. Okay, but the typical use case, or the use case which becomes complex, is the real-time kind of a use case where you need to do the inference at real time. Okay, and there are different kind of ways to do it. For example, if you are using a model repository to store your models, there is a good chance that you can apply a kind of a web service on top of it using fast API, Flask, or a choice of your technique to launch a web service on top of it. Okay, fast API is a good practice to use it. Many people use Flask also, but it is kind of I felt that fast API has performed better in terms of the model uh, uh, services which I have built. Okay, so if you see this, right, it becomes kind of a way that it becomes a kind of an engineering problem, that you have some model train, and now what you want to do is you want to make it available for production. Okay, and that's why it will, whenever you think about model deployment, you will also need some kind of a engineering mindset to think about it, how to scale it, how to think about the latency and the other requirement, which you'll see in the later slide of this particular talk. Okay, uh, few companies, actually I will say big giants, has already built their own data science platforms. Okay, For example, Uber has machine learning to do that. Okay, so whenever you are in a choice where you have some kind of a custom request where you need to do different kind of things which is not supported by like open source or the open platforms which are already there, then only it's recommended to go forward for building your own, because the time it takes to build everything, right? It is better to do the right kind of a research in open source domain to see that what all components, what all platforms, what all tools, what all packages you can combine to generate your end-to-end pipeline in the way you want. Okay, and if it requires some kind of a wrapper on top of it, definitely it's recommended to write. But building something end to end just for your use case could be an over engineering in cases if we have not explored all the offers. That's why I put it in red, and I've seen few startups doing that. And but it is always good to think about the open source as the first kind of a way to go forward. uh, Coming to the cloud world, if you're thinking about the deployment, it's quite easy. You can go for SageMaker, Cloud AI, Google Cloud AI, Azure ML. Okay, and there are different ways. For example, if I go for Azure ML offerings, right, you have Auto ML, ML Studio, Databricks. Okay, and pretty much what helps you, like as we discussed, Auto ML can help you in the fast prototyping. It will help you to fail fast. Okay, if you want to expose your models or if you want to do your prototype via product team, right, you can go ahead and say that, okay, I want to apply kind of a visual ML. Okay, you can use ML Studio for that. Okay, Databricks for your engineers to do the kind of POCs. Okay, using ML pipelines as we discussed in the pipeline section to set getting the right kind of a common functionalities in all in module and keeping those module reusable for different kind of pipelines. Okay, and people are using as Kubernetes is kind of standard. Okay, so people are actually migrated all their models or using the microservices to deploy using Kubernetes for the orchestration part, building Docker out of the image for the model, and then deploying it using Kubernetes. Yeah. So this is till this point, if you see, we have covered that, okay, how to think about the prototype, how to think about the model training, and how to think about the model deployment part. But one key point which most of the people actually miss is how that is going to integrate with the engineering system. And that's why I mentioned in the starting that when we are thinking as intelligence as service or model as service, right, this particular key point or this particular portion should be there in your mind, saying that if there is an engineering system A and which needs to talk to my intelligence service B, okay, what kind of interaction it will be. So first kind of a, which is kind of a well-known solution is, okay, maybe service A is calling service B, and that is the kind of a cleanest solution you get. In addition to that, if there is a kind of a latency requirement, or if you want to have a kind of a circuit breaker in between A and B, you can use Hystrix or some other equivalent on top of it to have the right kind of a communication between A and B. Okay, but there is a possibility that if you are in a high QPS environment where you say that, okay, when I'm calling from service A to service B, there is a lag. There's a lag of what you say, uh, because of the network latency or something like that. So in that case, there are companies who build solutions where you are training your model in a serialized manner using maybe MLE format, which is kind of very standard. Okay, and then loading those serialized models into your service engineering service itself, that is your service A for this particular example, right? So that way you can say that you have reduced your network latency part of it, and pretty much all those computations are happening in your service A. Okay, there are some disadvantages of this approach also, that you'll have additional maintenance of these things. There is an additional chance of breakages, but to deal with the kind of the QPS or to support those the latency and throughput requirement, there is a chance that one need to go ahead with this kind of a systems. Uh, this I'll say that this is kind of my favorite topic, and which says that, okay, when you're building a system, right, when you're thinking from prototype to production, right, you need to think about the how you're going to say that your model is healthy or not. Okay, and in that I'll say that when we say define the health of the system, we can say that we will have a model health, feature health, and the system health. When I say model health, you are pretty much capturing that on each of these runs, what is my one matrix. Okay, if I'm capturing F1 score, I should have track of all the F1 metrics of all the runs. I should know what is the best run. I should have the artifact or the serialized model for all those runs. And these things are quite possible from using ML flow, Kubeflow kind of a way to do it. And it is good that if you're thinking this thing from day one, using kind of a solutions like MLflow is just a it's a very easy job. Okay, and that way you can say that whatever you have run from day zero, you have actually think everything is captured, everything, all these artifacts, all these metrics runs are there. Okay, so that comes into the model health, and one should definitely do that, do this for sure, from all the experiments also. The second is the feature health. So when I say about feature health, when you build a model, right, you also take some kind of a assumption saying that, okay, uh, maybe this will follow this kind of a distribution, this particular feature will follow this kind of a distribution. So there is a chance that as the nature of the data changes, for example, in this COVID scenario itself, right, before COVID, post COVID, right, what is the kind of a change in the distribution of the data for a particular variable? There is a chance that it could have some kind of an impact. So all those things also can be captured. For example, I've used case kind of a test or Bhattacharya distance kind of a method to figure out that what is the difference in the distribution of a particular feature which is used in my model. Okay. And last but not the least, which is the kind of a system health, which pretty much everyone builds in the engineering system, and that will translate to the data science or machine learning system also, which is what is the kind of CPU utilization, memory, QPS, latency, the kind of exceptions and error count, right? And there are standard solutions to capture all this. What is that? You can think about Prometheus, Thanos setup, or Graphite Grafana setup. If you're on the Azure world, you can think about application and insights. So there are different ways to check the system health. So if you set up all these three, what will happen is, this is one time effort where you are able to set all this, and maybe you are ready for the different kind of runs. So you can say that your health of the system is now under your control, that you can at least know what is going on. Coming to ML at scale, which is kind of my favorite topic. So when it comes to ML at scale, when you're doing the prototype, it's not always will be in picture that what will happen, what kind of a compute to use, what kind of a cluster type to use, because maybe you are dealing with a lesser amount of a data, or maybe you are doing just kind of a prototype where the scale of the things are not that big. Okay, but if you know that you need to deploy it in production, because the topic which you are discussing is prototype for production actually. So in that case, you need to think about how to scale my training pipelines and how to scale my ML service pipeline, or the exposure which you have done. So if you think about the training pipelines, it can be easily scaled using the distributed setup, using Spark environment, using PySpark or Scala for the different kind of jobs, and choosing the right kind of a cluster type. For example, if I know that my job is a compute optimized, then choose those kind of a VMs. Memory optimized or ML optimized boxes are also there, right? So for all those things you can choose. And when it comes to scale ML services, horizontal pod scaling is kind of a solution which comes from the engineering domain, using protobuf kind of a request response. That will be very good for what you say, to reduce the packet size, and that will help you to basically increase your throughput, right? And if you combine your GRPs, if you make your internal services, if you have a lot of service, 500 services running in your background, right, and they communicate with each other, in that case, using a gRPC with protocol kind of a protobuf kind of a setup is a kind of a, what do you say, gold standard as of now for making things smart, start fast. Yeah. The last but not the least, which is basically the evaluation part, which is actually a tough job when you say that how your model is performing well in production. The first point is the controlled rollouts, which you should be clear from the day zero that if I'm building something, or there's a good chance, 99% of the cases, I'll be not going directly for all the traffic. Okay, so it will be mostly not live with all the traffic I have if I'm working in a big company, right? Because if something is running and if I need to try it out, right? So there are techniques like you can do A/B test kind of a setup. It's pretty much available in Kubeflow and different kind of ML platforms. Okay, or you can define your own also in your service if you're loading your model. So A/B test kind of a setup, you should have all those things in your mind from day zero to think about when the right time comes, you have you don't see any blocker like that. Okay, even if after doing all these things, right, there is a chance that you'll be not able to generate the outcome which is understood by business or what do you say, the product team. Okay, so in those cases there could be chances that you need to think about the offline reports which you need to generate based on the model performance on in production. Okay, and as we have seen the system health, definitely we need a type of an alerting on top of it if anything goes bad. For example, model training is happening, but that is maybe F1 score is going down. Okay, we should get an alert, we should get a call, we should get an email for that. Or the feature distribution is changing, maybe for that also we could get a call. Okay, ideally in my experience I've seen that if your model health and the feature health is actually reflecting your production behavior, that is the best shape to be in, because you cannot control that these things will not change or this will not degrade. Okay, but if you're able to know that in advance, or if you know that in the right moment, you have the buffer to fix it and you can go ahead with the alternatives. So this is the way I think uh, about moving things from prototype to production. And as this guy, this has just a lot of topics, so I'll say that maybe if you think about this mental map, that if you need to, when I'm writing my first next ML prototype, right, I have a kind of a tracking solution in place. I have the kind of a vision that how this will be exposed and as an service, or it is required to be a bad job or not, how I'm going to do the A/B test. Okay, so all those things, and what is the kind of a health monitoring system we need to apply, right? So if we have all these things in place, uh, moving to production will be a piece of cake where you are pretty much, you have followed the right structure to go ahead with that. Okay, so to end this, I'll say that we follow this kind of a practices a lot. I have this community where people are doing a lot of projects on machine learning. um, Most of the projects follow the same kind of a structure where you are using the right practices, or still few things are evolving. And if you're interested, maybe you can scan this QR code, or you can get access to my deck, and in that you can check it out, this link. Okay, and that's all. Thank you all, and let's get connected.